Shall we begin? Jaden, I hate memorizing. I'll memorize something if it's a very valuable shortcut, so there will be some times this year when I'll tell you ahead of time, you're going to be using this 600 times in the next 3 weeks. You probably want to memorize it instead of looking it up. But I don't want to memorize useless stuff if, with a minimum amount of thinking, and by that I mean like 2 seconds of thinking, I can derive it on my own anyhow. Then I say, you know what? Who needs it? So we're going to be talking about dimensional analysis, or this is often called unit conversion. How to convert from one type of measurement or units to another. And I'm going to try and do it without memorizing stuff because I'm naturally a little lazy. So I kind of divide these into two main types. There are what I kind of call one-step conversions, where all you're doing is getting rid of a metric prefix and you're ending up with the base unit. What I mean by the base unit is it has no letter in front of it. Grams is a base unit. Meters is a base unit. Liters is a base unit. Centiliters, not a base unit, that's got a metric prefix in front of it. So when I say the word or the phrase base unit, I mean just the single letter by itself. Two-step conversions are where you're going from one metric prefix to another metric prefix. 2 steps. And then we'll kind of go into multi-step chains. So, using metric prefixes, it says convert the following. 12, capital M, lowercase g. What is a capital M an abbreviation for? It's on your green sheet. Yeah, by the way, when I ask you that, I didn't mean you had to memorize it or no. It's on your green sheet, but you need to know where to find it. Mega, okay. So convert 12 megagrams to grams. I know mega means a million. I think the answer should be 12 million grams, but I'll show you how to get there systematically. First thing that I always do is I write down what they gave me. What did they give me here? 12. And for a single step conversion like this, again, Daniel, what I mean by a single step conversion is we're just getting rid of the metric prefix. I'm going to take some shortcuts. All I do is I multiply and replace that mega with its power of 10. What is the power of 10 from your green sheet that I can replace mega with? 10 to the 6th. And again, you can memorize that if you want. I don't. It's on my sheet. This is what I'm going to type on my calculator. Now, we have to be careful, Bryce. The most common mistake is students, because that's a 10, they think this is scientific. This is not. I realize, creature, it's also a 10. And scientific notation was 10 to the, and you used your scientific notation button in scientific notation. You're not going to use your scientific notation button here for metric conversions. You're actually going to just type it in. 12 times 10 to the 6th. You get that. Final answer, unless I say different in the instructions, Jordan, I don't care whether you write it in scientific notation or standard form. I think here it would be shorter to write this in scientific notation. I'll write it in scientific notation. If the answer was that, 1200, I'd probably just write it as 1200 because it's more work to write it in scientific notation. So unless the instructions mean us say, give your answer in scientific notation or give your answer in standard form, pick. And I'll take both. I want you to start to realize scientific notation is a useful tool as a shortcut, but it shouldn't be a drudgery, mandatory, you must write it this way, you must pick. So I'm going to go 1.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, because that's less writing. So Sally, the first thing I want you to realize is for a single one-step conversion, I can replace the metric prefix with its 10 to the. 13.6, what's a lowercase m stand for? Milliamps. I remember A was amps. Okay. I'm going to write down what they gave me. What can I replace milli with? Come on, it's on there, isn't it? Yep, times 10 to the negative 3, and now I'll go to my calculator. 13.6, this is not scientific notation. I'm not going to use my scientific notation button. I'm actually going to go times 10 to the power of negative 3. And apparently I get, would it be easier to write that answer in scientific notation, or is it easier to write that answer as a decimal in standard form? I'm going to write it as a decimal, 0.0136. Since the instructions didn't specifically say. Amps. Those are one-step questions, Jordan. And all you do is replace the metric prefix with its 10 to the power of. Two-step questions. What do I mean by a two-step question? Paige, can you see I'm starting with one thing in front of the grams, I'm ending with a different thing in front of the gram. 2 steps. I'm starting with one thing in front of the N, in front of the L, I'm ending with 2 steps. Starting with one thing, ending with a different thing. 2 steps. You know how I'm going to start a 2-step? The same way I started a 1-step. I'm going to write down what they gave me. But this time I'm also going to include the units. So I'm going to write down 13.6 kilograms. And I'm going to introduce you to the idea of what we call a conversion chain or a conversion factor, a fraction. Fractions, the math F word, not the F word you're thinking of. Fractions, though, aren't too bad. Here's what I mean. I want to, first of all, get rid of kilograms and end up in just plain old grams. That's going to be step 1. Step 2, I'm going to get rid of grams and end up in, by the way, what's this symbol? How do I pronounce that there thing there? Micrograms. Okay? So how am I going to do that? I'm going to multiply by a fraction. Draw a vertical fraction, not a slanty fraction. So I drew a horizontal line right in the middle. I want to get kilograms to vanish. In math, we often say to cancel. So in this fraction, I'm going to put kilograms on the bottom. Why on the bottom? Because up here it's on the top because it's over 1. And I want to go to grams on the top. Now this is wrong right now, Kennedy. Grams and kilograms aren't the same thing. So this would be mathematically incorrect. But what can I replace a lowercase k with? Green sheet. 10 to the what? Sorry? On the top, instead of a kilo in front of the grams, I'll put a 10 to the 3 in front of the grams. And Connor, I'm arguing, those are the same thing mathematically, but what this lets me do, Mina, is go cancel, cancel, and now I'm in grams. But I don't want to stop there. I want to end up in micrograms. I'm going to multiply by another fraction. This time, I want to get rid of grams in this fraction on the top or on the bottom. In this fraction, where is grams? On the top or on the bottom? Where in this fraction is the G not on the top? On the top. Can we agree that here it's on the top? Where do I want to put that in the next fraction so that it cancels? There we go. And on the top, I'm going to put micrograms. But this is nonsense. Micrograms and grams, Aaron, aren't the same thing. Putting a micro up here is the same as putting what power of 10 down here. What's micro the same as? Read from your green sheet with less delay.
10 to the negative 6.
Okay. Cancel, cancel. Now, the reason I use this method, Mina, is the most common question kids ask is, Mr. Duke, do I multiply or do I divide? Hey, if the 10 is on the top, it's going to be. If the 10 is on the bottom, it's going to be. If the 10 is on the top, it's going to be times. Everybody, if the 10 is on the bottom, it's going to be divide. So on my calculator, I'm going to go 13.6 times 10 to the 3 divided by 10 to the negative 6. and I get that. Oh, I get an answer in scientific notation, so I'll write this answer in scientific notation. I get 1.36 times 10 to the 10th micrograms. Now this seems a little weird. It is at first, but when you wrap your brain around it, you'll find it cuts your need to memorize in like a zillion. You can really get away with memorizing very little. What you have to remember is you're going to multiply by a conversion factor, a chain. If you want something to cancel in the fraction, it goes on the opposite level than it was previous. If your previous one was on the top, in the fraction you'll put it on the bottom. If your previous one was on the bottom, in the fraction you'll put it on the top. Then you have to remember that numbers on top are times, numbers on the bottom are divided. Let's do a bunch more. Raven, what does a lowercase n stand for from your little sheet there? Nano. We want to convert 2,000 nanoliters into megaliters. Okay. You know how I'm going to start? The same way I've started every other question. I'm going to write down what they gave me because I feel better and it's no longer blank. So I'm going to write down 2,000 nanoliters. I think I told you, but I'll repeat myself. Don't write liters like that, because what does that L look like? A 1. So I will always, in fact, you can even see in my type font, I found the cursive curly L, so you can clearly see it's an L and not a 1. It's a good habit to get into. First thing I want to do is get rid of nanoliters. Where am I going to put it in the next fraction then? On the bottom. And I'm going to go plain old liters on top, what I call the base unit. And the 10 to the goes here. I already have a 10 to the as a letter right there. That n is 10 to the negative whatever it is. But I have to have that same thing as a number here where the letter is not. What is nano? 10 to the Raven negative what? You found it on the chart? Is it negative 9? Yes, that was a total guess. And Raven, if I stopped here, if I went 2,000 times 10 to negative 9, that would get me liters. Because can you see that's the unit that's sitting by itself? Now I want to get rid of liters and end up in megaliters. Okay. Can you see liters is on the top in this fraction? Where am I going to want it in the next fraction? Bottom, you say? What do I want on the top? What I want to end up with? Megaliters. By the way, this is why I call these 2 steps. Step 1, step 2. Except this is nonsense. Here I have a mega. Here I have to put the 10 to the, because this liters doesn't have anything in front of it. It's the base unit. Mega is 10 to the, oh, Raven, keep going. Mega is 10 to the what? You've been on a roll. 10 to the 6th? Good. And I'm now left with megaliters. Now what I'm going to type on my calculator, and again, Kennedy, the reason I use this method is it answers whether I'm dividing or multiplying. Numbers on top, I'm going to times. Numbers on the bottom, I'm going to divide. So on my calculator, I'm going to go 2,000 times 10 to the negative 9 divided by 10 to the 6th. And I end up with, oh, I get an answer in scientific notation, 2 times 10 to the negative 12 megaliters. Mr. Perugia has showed you a similar method, I think. Yeah. Quickly, buddy. That's why I just rewrote it. It's a negative 12, by the way, but yeah. I look at number 5. Instantly, I know it's a 2-step because I'm going from a K to an M. Okay. Conlon, you know what I'm going to do first? The same thing I've done first for every other question. What am I going to do first? Write down what they gave me. Yeah. By the way, I am big on writing something down almost before you start. One of the things I've learned, I've taught for a while, is a blank question is intimidating. So you're going to see one of my teaching strategies. I'm going to, Kyle, try and build into you habits so that when you see a certain question, the first thing you think is, oh, I write this down. Now your question's no longer blank. So I'm big on that. So for unit conversions, it's always, I write down what they gave me because it's no longer blank, I feel better. Here they gave me 342.5 kilometers. Colin, I want to get rid of kilometers. Where is it going to be on the next fraction? And on the top, I'll go just to plain old meters, except I can't just put an M up there. Mathematically, that's not valid. What I want instead in front of the M is to replace the K with the number that K represents. What does K represent on your green sheet? I don't think it's 10 to the 6th. Please tell me it's 10 to the 3rd, or else I'm... Boy. You getting your driver's license, Zach? You better get that one okay, because otherwise you're going to get a lot of tickets. Just saying. I'm going 10 to the 6th meters per second, officer. Yeah. And you're passing jets. In fact, you'd almost be passing the space shuttle, but not quite. Space shuttle goes about 11,000 meters per second. Colin, see the kilometers have canceled? But I don't want to end up in meters. I want to end up in millimeters. Okay. So now I'm going to get meters to cancel. Millimeters goes there. Except down here in the bottom this time, always in front of the unit that doesn't have a letter in front of it. That's where I'm going to replace the 10 to the milli is 10 to the what? 3? Okay, that's important. Makes a big difference. So on my calculator, I'm going to go 342.5 times 10 to the 3rd divided by 10 to the negative 3. And once I write it out like that, by the way, you get good at this. It takes you about 1 second to write out the chain, and it gets rid of, do I divide or do I times? It's in the question, in your solution. Is that okay, Jordan? Times 10 to the 3 divided by 10 to the negative 3. And I get, is that number going to be easier to write out longhand in standard form or to write in scientific notation? Well, let's write it in scientific notation. 3.425 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 3.425 times 10 to the 8th. Jaden, I'm fussy. Units matter. Parmjot, I will take marks off if you don't put units on your final answer. I will not take marks off in the middle of your work, but a good habit to develop for the rest of the year before you hand in any quiz or any test. You go to any written questions and look at your final answers and make sure that they have the correct, what's the word I'm looking for? Units. Units can make a big difference financially. Put your pencils down, look up. So again, for those of you who are watching at home, Google Verizon can't count, and you'll find the whole saga. I will say at the very, very end of the phone call, he does say a little Simba bad word because he's had enough, but he's patient the rest of the way through, so I have to give him at least some credit. I hate memorizing stuff, Asia. I'm not gonna. So one of the nice things about this idea of building a conversion chain is you can use this to derive a whole bunch of values, Leah, that you actually know without knowing. Say what? Part C, multi-step conversions using conversion factors. And the first one, number 6, says, how many seconds in 1 week? I always pause here and I ask, does anybody know how many seconds there are in 1 week? Do you know?
I don't.
Okay. I don't. And the reason is it's a waste of my brain. I can calculate it by making a fractional chain. Conlon, you know how I'm going to start out? I'm going to start out the same way I've started out every other question. I'm going to write down 1 week, because they want me to end up in seconds. So all of us, let's write down 1 week. And I'm going to multiply by a fraction, a conversion factor. Hey, I don't know how many seconds are in a week. What can I break a week into? What dimension do you all know fits into a week, and how many? Okay, let's convert to days. Now, where is weeks in this first fraction? It's on the top because it's over 1. So where am I going to put weeks in this second fraction? So I'm going to put weeks and days. What's the conversion factor? How many days is how many weeks? 7 days, 1 week. And you know that. This is nice. We don't have to memorize something new. You've memorized this one already because of calendars on your own. Are we done? Well, no. This would be in days. What do I want to end up in? Seconds. Okay. Does anybody know how many seconds there are in a day? Someone might. Oh, okay. What can I break days up into? Hours? Do you know? Someone said minutes. Do you know how many minutes there are in a day? No. Well, then hours. I don't either. I never bothered memorizing it. So, Zach, where am I going to put days in the next fraction? Top or bottom? Bottom. And I'm going to put hours on top. What's the conversion factor, Zach? How many hours is how many days? 24 hours. The 24 goes next to the hours. 1 day. And if I stopped there, that would give us how many hours in 1 week? Minutes? I can convert hours to minutes? Sure. Hours is going to be on the bottom. By abbreviating minutes, why would that be a bad abbreviation for minutes? Looks like meters. Okay. Minutes, we abbreviate MIN. Not MI, because MI is taken by the US miles. How many minutes and how many hours? What's the conversion factor? 60 minutes is the same as 1 hour? Okay. That would give us minutes. Are we done? What do we want to end up in, Kennedy? Oh, I know how many seconds are in a minute. See, this is how you can build a chain and just hopscotch your way there with knowledge that you already have in your brain. I really like this method. So I want minutes to cancel, Kennedy, seconds, and you're telling me 60 seconds is 1 minute? And then the rule I told you, if the numbers are on the top, we multiply. If the numbers are on the bottom, we divide. And I'm going to ignore the ones, like timesing by 1 and dividing by 1. I mean, it's not going to make a difference at all. So I guess it's going to be 7 times 24 times 60 times 60, which you probably, some of you could have done intuitively, but by writing this out, it takes 2 seconds, and you know you're doing it right. And for questions, this is still going to work. By the way, I'm lazy. I went 60 squared because it's 60 times 60, and I have a squared button. Do you get 604,800 seconds in 1 week? Is that right? Okay. Oh, my pen just started going haywire. Hang on here. I got to pause the video for 1 second. So I got, what was it? 604,000. 604,800? Is that right? No, this is wrong. Second. Yes. I'm going to be fussy on units. I would have taken a half mark off. Okay. How many hours in 1 year? I don't know. I can figure it out. I want to end up in hours. I'm starting with years. Hey, what's the first thing I'm going to do? 1 year. There, I've written something down. I feel better. And it gives me now my plan of attack. I need to get rid of years. So here's my question. What can you break years down into? I'm going to go days. And the reason I'm going to go days is I could go months as exactly 12 months in a year. 52 weeks actually doesn't quite work because there isn't exactly 52 weeks in a year. It's 52 and a bit. There is, by definition, 365 days in a calendar year, not in an astronomical year, which is why we have leap years, but in a calendar year. So I'm going to go years cancel days. What's the conversion factor? How many days is 1 year? You've all, I think, memorized that because you're young adults. Now what? What can I break days into? Oh, hours, and I'm done. Where is days going to go in my next fraction, top or bottom? Bottom. By the way, what if days had started out on the bottom here? Where would it go in the next fraction? On the top. And we're going to come to somewhere stuff is on the bottom already too. Hours, what's my conversion factor? 24, 1. Oh, it's going to be 361 times 365 times 24 divided by 1, divided by 1. I'm going to ignore the ones. You get 8,760 hours. So think back to last year, at the very beginning of the year when you were starting out grade 10, and it's been almost 9,000 hours since then. Just putting that in perspective. Every year, it's just shy of 9,000 hours. Carpe diem, gather the rosebuds while ye may, or whatever you want to say. Is that all right? Let's do another one. How many seconds in 1 year? Pardon me? A lot? Oh, by the way, on your test, I am going to give you a couple of questions like this. I'll ask you to convert like years into seconds or something into something else. And it'll be by using knowledge that you know to build a chain. So, how am I going to start this out? What am I going to do first? Sarah says, write down what they gave you. Sure. 1 year. What can I break years down into? If I'm really clever, what can I break years down into now that I've done example 7? Oh, hey, I have a whole new conversion factor. Now, if I didn't have that, I'd go days, and you know what? I can go straight to hours now because of that. It's exactly 8,000. Okay, I can do this. I want years to cancel, and I can go to hours, and it's 8,760 hours is 1 year. So don't be scared to use something that you've already calculated to find something else as a little shortcut. Anybody know how many seconds there are in an hour? 36. Okay. Sarah knows that there's 3,600. She noticed that it's 60 times 60. Sarah, since you gave us that, we'll use it. My last class, nobody knew, so we went to minutes, and then we went to seconds. But since you know this, I'm going to say 1 hour, second. You told me 3,600 seconds is 1 hour, and look at that. We did it in exactly 2 steps. Great, we'll take that. Double check the units. Sarah, do the hours cancel? Yes. Do I end up in seconds? Yes. And I guess it's going to be 8,760 times 3,600. I get 31536 and 3 zeros. Mr. Dewick, what do we round off to for sig figs? You know, here, go to the full value. 31536, 3 zeros. 31536. Units, seconds, 31.5 million seconds. So go back to the beginning of last year. Remember yourself at the beginning of school. Here we are now. It's been about 31.5 million seconds since then. Every birthday, you've lived another 31.5 million seconds. Ooh. So this is the build a fractional chain conversion factor method. Mr. Perugia kind of showed you a similar thing, yeah? And he might be emphasizing a slightly different approach, but it's going to be the same strategy for chemistry. The reason I like this is you can use this if they give you some conversion factors. So we're going to go to the imperial system. Number 9 asks, how many centimeters in 1 mile? And I've given you a bunch of conversion factors here. 4 gills is 1 pint. What's a gill? This is the U.S. system. It's stupid. Anyhow. Number 9. How am I going to start out number 9? Going to write down 1, and I'll abbreviate mile, MI. M would be meters. I'd be worried I'd forget. MI, and is minutes, MI, miles. Do I have any kind of a conversion factor for miles? I do in this chart. What can I convert miles to in this chart? Feet. See it? Right there. So I want miles to cancel. Feet go there, and apparently it's 5,280 feet is 1 mile. What a stupid conversion factor. US, what a stupid system. Well, what do I want to end up in? Centimeters. Do I have a conversion factor here at all for feet to centimeters? No. What I do notice, Kyle, is a conversion factor from inches to centimeters, and so now I'm going to gamble. You live close to the United States, especially if you play sports. You probably know how many inches there are in a foot. How many inches are there in a foot?
12.
I'm going to gamble that that's also part of your arsenal already, that you've memorized that already, Lexi. I think that's reasonable. You've seen rulers. We live close to the U.S. We still tend to measure our height in feet and inches. So I'm going to say, okay, feet cancels, inches, and 12 inches is 1 foot. And now I can go from inches to centimeters. I have a conversion factor right there. I can get inches to cancel, centimeters on the top, and apparently 2.54 centimeters is the same as 1 inch. I guess I'm going to end up going 5,280 times 12 times 2.54, and I'm going to ignore the ones. How do I know times for all of these? Because they're on top. I get 160,934.4. And why am I wrong? Centimeters. Number 10. I like number 10. I like number 10. I like number 10. Number 10 is a nice question. Jordan, why would I say that? Why would I say I like number 10? I like number 10. I like number 10. Number 10 is a nice question. Did you hear me say it's going to be on the test? Or you're the kind of student that notices when a teacher emphasizes certain things? Okay. By the way, what I mean by that is this is a two-step. We're going to have to convert miles into meters and hours into seconds. We're going to be doing 2 conversions in the same question. No worries. We're just going to do one at a time. And I'm going to start out the same way. Mina, how am I going to start out? The same way I've started every other question. How am I going to start out? And, ready? To make this easier for me, I'm going to write the fractions as clearly nice vertical fractions, not slanty ones, so I can see what's on the top, what's on the bottom. Is that okay, Aaron? And I think here is my strategy. I'm going to need to convert hours to seconds. I'll do that. And I'm going to need to convert miles to meters. I'll do that. Aaron, which one do you want to do first? Doesn't matter. Oh, sorry. Hang on. Look up. I wrote min. Miles. That was dumb. I caught that. You want to convert miles to meters or you want to convert hours to seconds? Doesn't matter. Miles to meters? Okay. So step 1. Where is the miles right now on the top? Where is it going to be in my next fraction? What can I convert miles to? What can I convert miles to? Feet? Psst. Everyone look up. What can I convert miles to if I'm really clever? And going from centimeters to meters isn't going to be very tough. Well, let's use that. So I'm going to go, you know what? I can go centimeters, 160,934.4, and I'm already from miles to centimeters. Now I want centimeters to cancel. Oh, and I can go from centimeters to meters. How do I do this one? With the metric prefixes, we said you replace the letter in front with the power of 10. So Aaron, what is centi? 10 to the... It's negative, I remember that. Negative 2? Okay, cool. Cool. Now what? Oh, let's... We're now in meters per hour. If we stopped here, if we went that times that times that, that would be meters per hour. Now we got to get rid of the hours. Now here's the issue. Aaron, where is the hours in this first fraction? On the top or on the bottom? So in the next fraction, to get it to cancel, where am I going to put the hours? Brilliant. You see it on the top. And again, it tells you then whether you're going to multiply or divide. So hours. Sarah, how many, did you say you knew how many seconds there were in an hour? So I can go hours to seconds. 1 hour is 3,600 seconds. And notice the 3,600 is on the bottom. So with that number, am I going to times or am I going to divide? Divide. That's how I know. I don't have to figure it out. My chain tells me. On my calculator, I'm going to go 60 times 160,934.4 times 10 to the negative 2 divided by 3,600, and apparently 60 miles an hour. Now, I know a little bit of a trick. I know that if you divide miles per hour by 2, that's roughly meters per second. 60 divided by 2 is 30. You're going to get an answer just a little bit below 30. Try me. Do you? Like, I'm going to guess 26, 27-ish, somewhere in there? Yeah? Oh, how about, let's call it 26.8. And that is meters per second. Yeah. I got rid of the centimeters, because is there a centimeters on top here and on the bottom here? They canceled. What of length that got left behind? Meters. And I could now go cancel. Whoop, didn't want to erase, Mr. Dewick. Your pen. That hours and that hours cancel, and I'm left with seconds on the bottom. Yeah. Quick click button. There's 8 minutes left. Can you wait? Yeah. Let's do that. I'm going to go right to the tone. You're not going to have any homework. We're going to finish this next class. Okay? Turn the page. Let's win the lottery. Let's win the lottery. Ready? This is accurate. Gloria McKenzie in 2013 won $590.5 million in the Powerball lottery. As far as I know, that's still the record for a single person winning a prize. And you've wondered questions like this. So here's our first question. If she spends $1,000 a day, how many years will it take her to spend the money? Can she spend it in her lifetime? Let's find out. How am I going to start this question? How did I start every other question? 590.5 million. So I'm going to write down 590.5. I know that million is 10 to the 6th. So I'm going to write, instead of the word million, times 10 to the 6th. That's dollars. How much is she spending? She's spending $1,000 per day. So I'm going to divide this by 1,000, and that will tell me how many days. And then I'm going to convert that to years. So on my calculator, I'm going to go 590.5 times 10 to the 6th divided by 1,000. If you have that many $1 million and you're spending $1,000 a day, it'll take you that many days. 590, 500. But I want to convert that to years. Hey, do we have a conversion factor to go from days to years? Oh, what's the conversion factor? I'm going to put the days on the bottom, years on the top. 1 year, 365. Oh, because that 365 is on the bottom, am I going to times it or divide it? That's what tells me. So divide by 365. If she spends $1,000 a day, Will she be able to spend that in her lifetime? No, it'll take her 1,600 and, oh heck, let's round off, 18 years to do that. And that deserves an exclamation point, I think. That exclamation point isn't a unit, it's a holy schmoly. All right, let's spend faster. Come on, you've wondered questions like this with the big lottery winnings, haven't you? You've never wondered how much money you could spend? Kennedy, let's go, instead of $1,000 a day, let's go $500 an hour. Okay? Hey, how am I going to start this question? How have I started every other question? I'm going to write down what I'm starting with, which is 590.5, and then million is 10 to the 6th. But now we're going to divide by 500, because that should tell us how many hours it's going to take. If she's spending that much per hour, divide by 500, that's how many hours you're going to need. And then we'll convert that to years. 590.5 times 10 to the 6th divided by 500. So it's going to take her 1181 and 3 zeros. It's going to take her 1181 and 3 zeros hours. Can she do that in her lifetime? Let's convert that to years. Don't we already have earlier in our notes a conversion factor to go from hours to years? Can someone double check? I think we can, can't we? We can get the hours to cancel. And what was it? 1 year is how many hours? 8,700. Okay. If you're spending $500 an hour, 24 hours a day, not sleeping, can she do that in her lifetime? Nope. 135 years she'll be dead before she spends the money. I mean, it's a nice problem to have. What was it? 134.8 years. Is what a 7?
Yeah. Oh, okay. Thank you.
Actually, lotteries don't quite work that way. If you ever, Cadgel, win a big lottery, if you want the whole prize, they actually pay it out over 25 years in installments. Or they'll let you take a smaller portion up front. So even though she won $590.5 million, she took the upfront payment of $371 million, and by the way, paid no income tax because she lives in Florida. Usually you lose about half of it to income tax, but Florida is a state that has no tax. How many years would it take for her to spend this if she spent $10 a minute? Could she do that in her lifetime? $10 a minute. Will she get that spent? Well, how am I going to start out this question? The same way I've started out every other question. I'm going to write down what?
What they gave you.
371 million.
Dollars.
And I know million is 10 to the 6th. And I'm going to divide this by $10 per minute, and that will tell me how many minutes it would take, and then I'll convert the minutes to years. 371 times 10 to the 6th divided by 10. I missed the 1. Let's try that again. 371, that'll make a difference. And I get 371 with 5 zeros. Minutes. We'll find out if she can spend this in her lifetime next class.